It's simple mathematics. Check it out. I'll revolve around science.
What are we talking about here?
I'm wondering how much aluminum went into this can, and I'm wondering if we can figure it out. We know we're not looking at what's inside the can, how much material went into making the can. What critical information do we need to know in order to calculate that? All right, I'm going to go ahead and open this can. All right, so I got the lid off. Okay, all right, now we can look inside. It has, all right, there's two of these, basically, about the same size. Okay, two of those. All right. And then there is this. Flatten it out. And I'm going to flatten it out. Whoops, bent the corner there. All right, how much aluminum is in the tin can? So I'm wondering if we can figure out what that is. All right. So there's my can going back to shape, sort of. All right. There's my bottom. There's my top. All right. And there's my can. So, how much aluminum is in this can? Okay, you can kind of see that the height of the cylinder is roughly 6.5 or 5.5 centimeters, or 5.5 centimeters. Okay, so that's the height of the cylinder. So you should go ahead and record that. And we can see that the diameter is roughly about 6.5 centimeters. Okay, now the angle might be a little weird on the computer or on the TV, but it's about 6.5 centimeters is the distance across that. Okay, so what do we know? Well, we have a cylinder, and the height was roughly 5.5 centimeters, and we know that the distance across was roughly 6.5 centimeters. Okay, now we saw that the can had the lid, had the bottom of the can that we cut off, and then we flattened out the can part, and this part, okay, if we thought about it, the corners would kind of go together like this. Kind of like so. Okay? So here we'd have the corners, and they would go together, flattened out. Here's one corner. Here's the other corner. Huh. How do we figure out this? Because we're looking for the area that's going to cover this, right? Aren't we? And we need to know how much metal's here and how much metal's here. So I'm wondering if we can figure out how that all goes together. How do I get the area of this? Well, this is pi r squared. And that's pi r squared. So we have 2 pi r squareds. Using a little algebra, we have 2 pi r squareds. We have 2 of those. Then we need to add them to this. Well, we have the height, which is the height of the can. How do we calculate this length here? Well, if we look, there's this length around here, is it not? Which is the same as what of the circle? The circumference. Same as the circumference. Well, how do we get circumference? We remember it's 2 pi r. So therefore, we can calculate the surface area of a cylinder as 2 pi r plus 2 pi r squared. All right. So in our case here, we end up with 2 times 3.14 times the radius, which is half of 6.5. And we're going to add that together. 0.41 equals, okay, 86 decimal 7475, I guess. 75. Therefore, the amount of metal in this can is 86.75 centimeters squared. All right, that's how much metal is in this particular can.
It's simple mathematics. Check it out. I revolve around science.
What are we talking